In identifying functions, there are four types of functions, which are one-to-one function, which is a function; many-to-one function, which is also a function; one-to-many function, which is not a function; and lastly, many-to-many function, which is also not a function. Relations is the matching of items from set A to set B. Relations can be represented by using arrow diagram, graph, and ordered pair. Graph of functions is a representation of a function with a straight line or curve on the Cartesian plane. Table of values is a table that shows values for independent and dependent variables, and it is constructed before a graph is drawn. Okay, so today we are going to learn about the graphs of functions. In this topic, it involves four types of graphs, which are linear, quadratic, cubic, and reciprocal graphs. Okay, so first we are going to start with linear graph. For example, we have y equals to x plus 1. Okay, so this is the graph. Okay, first of all, you can change the ratio of the graph however you want. For example, if you want 1 to 2, then it will change. Okay. And then you can also view the positive direction only, so it will appear like this, especially for students if they want to print the graph. Okay, so you can also label it. For example, for x-axis we will use height, and then for y-axis we use weight. Okay, so as you can see, there will be label here. Okay, you can also change the color of the graph, the style, however you want. Okay, so for the function, okay, this is the function. If you click here, you will see table of values and special points. If you click on special points, you will see two things that are root and intersect. So the root of the function is -1, 0, which is A, and then it intersect, which is B, of 0, 1. And also if you click on the table of values, you can, okay, we start with -2 and end with 2, so we will be able to have this table, and the points are also plotted on the graph. Okay, we go to quadratic graph. For example, y equals to x to the power of square minus 4, 3. Okay, we make some adjustment here. We change y to fx, so that we can call a function on it. So if, for example, you want to know what is f3, we can calculate the GeoGebra graphic calculator will calculate it for you. So it will be f3 is 6. But you can also use the table of values. So we use, okay, -3 until 3. So you will get the value, which is 6. So you can use both ways, which end up with the same answer. Okay. How about cubic graph? Okay, x to the power of 3 plus 2. Okay, so this is how the graph goes. And if we click on special points, you will see the root, extremum, and intersect. So the root is A, and intersect is C. Okay. And lastly, we try out the reciprocal graph. One okay, 3 over 2x. Okay, so as you can see, the special points are all undefined. So this is how it goes. With this, using this graphing calculator, you can also save it, download and print. So it's easier for students to do their graph here instead of doing the manual graph on the graph paper. So the game is called Avoid the Mines. So the instruction is an attacker chooses 5 landmine spots which consist of 3 points per spot. It may be horizontally or vertically but not diagonally. Draw them with a pen and hide it when you are done. The defender must write 5 linear graph functions that avoid the points the landmine occupies. You must not use vertical or horizontal lines. You may hit more than one landmine with a single line if you are unlucky. Mark an X on any points you have hit. You win if you avoided 7 or above out of 15 points of landmines. Okay, so in this game, there are a total of 81 points. So the first step is the attacker have to choose 5 landmine spots which consist of 3 points per spot. So out of all these 81 points, they have to choose 5 spots which consist of 3 points, so that the total is 15 spots. So they have to draw it with a pen. Okay, so the first spot is this, the second spot, the third spot, and the fourth and the fifth spot. Okay, so after the attacker has chosen their spots, they have to hide it again so that the defender can guess and avoid which the spots are. Okay, done hiding. After that, the defender must write 5 linear graph functions to avoid the points that the landmine occupies, and the defender cannot use vertical or horizontal lines. So, okay, this is the first function, the second, third, fourth, and fifth. So how do we know if the defender wins or not? They have to avoid 7 or above out of 15 points of landmines. Okay, so we have to unhide the spots that the attacker has chosen. So, okay, we have to see how many points the defender hit. So in this example, we cannot see any of the points the attacker has chosen that has been hit by the defender. So this means that the defender has won the game.
Example 1. 1a. The following table shows the corresponding values of x and y for the equation y equal to 2x power of 2 minus x minus 3. So in the table, we have values of x and y. Values of x are negative 2, negative 1, negative 0.5, 1, 2, 3, 4, 4.5, and 5. And values of y are 7, m, negative 2, 3, 12, and 33, and 42. The question asks us to calculate the value of m and n. For 1b, for this part of the question, use graph paper. You may use a flexible curve rule by using a scale of 2 cm to 1 unit on the x-axis and 2 cm to 5 units on the y-axis. Draw the graph of y equal to 2x power of 2 minus x minus 3 for x greater than or equal negative 2 and less than or equal to 5. 1c, from your graph, find first the value of y when x equal to 3.9 and second the value of x when y equal to 31. So here we have our equation. Y equal to 2x power of 2 minus x minus 3. And then choose 3 dots there, table of values, and then start value for x is fill -2, and value for x is 5, step is 0.5. Press OK. Okay, then we get our table of values. So we get the value for m and n there. Okay, done for 1a. And then for 1b, the equation asks us to draw graph 2 cm to 1 unit for x-axis and 2 cm for 5 unit for y-axis. So when you go to settings and set y-axis as 5, x-axis as 1. So we get 2 cm to 1 unit on x-axis and 2 cm to 5 unit on y-axis. And then we settle our 1b. We go to 1c. So 1c asks us to find value for y when x equal to 3.9. So the grey line, we go to 3 dot there, and then we change the color red. Okay, now we can see the red line, and then we go to tools, points, and then we select the points there, and then go to the again settings, color, and then blue. So the blue point is our point, so there we can get 3.9, 23.5. So y for y is 23.5 when x is 3.9. When y is 31, we must find the value of x. So we do the same things, change the color first. Okay, so we can get here green line with tools, points. You can select the points. Okay, then we go settings, change color. Okay, now here we choose orange color. So the point orange color is for y. So the x is 4.4.